So I have completed my BSc Agriculture from Nursery Agriculture University. Then I have completed my Masters and PhD in the subject of Genetics and Plant Breeding from Nursery Agriculture University. Following my doctorate studies, I have worked as an assistant professor for 3 years at Lovely Professional University and Savan University. Then I joined as a research associate at Wheat Research Station, Nursery Agriculture University, Bardoli. And today I'm going to host this session on augmented RCBD analysis, its theory, layout, analysis, and interpretation using our Agri Analyze platform. And before we start, all participants are requested to please register yourself on our Agri Analyze platform. If you do not register on our platform, then you cannot perform the analysis. If any of the participants have not registered to our Agri Analyze platform, you have to go to the Agri Analyze platform like this, and you have to go to the register. Once you go to the register platform, you have to add your details and you will be registered to our Agri Analyze platform. So you can use our tools for analysis in further session. Okay, so please do that. So these are the contents of our webinar: why we need to use the augmented RCBD design and when to use it, and how to prepare a layout and blocking and data arrangement for our experiment. And after data arrangement, how we can analyze our augmented design in our Agri Analyze platform. After computing our data in Agri Analyze platform, after estimating the block effects, we are going to interpret the results. And in the end, we will see small case study on augmented mating design. So this is the introduction. So the basically augmented design was first proposed by William Federer in 1956. And the augmented design is the experimental design in which large number of unreplicated test entries or large number of accession or large number of germplasm are evaluated along with few replicated check varieties to adjust the environmental variation. In RCBD design, our test entries or our genotypes are replicated, but in case of augmented design, our test entries or our genotype or our accessions are non-replicated, but our check varieties are replicated. Our check varieties are replicated to minimize the environmental variation which is available in all our blocks. So when we can use this augmented design, when we have to use this kind of augmented design instead of RBD design, okay, so we are using this kind of augmented design when we have a less area in the field, when we have a large number of genotype, we have a large number of accession, then we can use this kind of augmented design. And when we have a less number of seed, when we have a very minimum amount of seed with us for our accessions or for our germplasm, then we can use this method. When the labor and resources are limited, then we can use this method. And when our objective is to screen, not for precision, okay, when our motto is to screen the material, large amount of material we have, and we have to just screen them, then we can use the augmented design. For advanced replicator, for advanced trial, for a variety release trial, we cannot use this kind of method, matching experimental design. We can use this for initial screening. Then test entries, which test entry or which entries or which accession we can analyze. We can screen the germplasm, the accessions, or we can also screen the segregating population like F2 and F5 generations. We can also screen the hybrids, and we can also screen the mutant or any elite lines, which are available in a large quantity, and the seeds are limited in number. So the difference between RCDB and augmented RCDB design. So in this table, you can see that in RCDB design, all the treatments are replicated, but in the augmented RCBD design, only checks are replicated. While number of entries are very small or medium in RCBD design, while the number of entries or accessions are very high or very large in number in case of augmented RCDB design. The precision of RCBD design is very high, while the precision of augmented RCBD design is moderate. While the resources are needed for RCDB is very high, and the resources are needed for augmented RCDB is very low. And this RCDB design used in advanced trial, while the augmented RCBD is used in a early screening for initial screening of our germplasm. And these are the advantages. We can evaluate the large number of new genotypes with limited resources. When the resources are very limited and the genotypes are very large in number, the accessions are very large in number, we can use this method easily. It requires fewer replications, saving time, labor, and cost. And also it's suitable for a preliminary screening or initial screening of germplasm or breeding material. And its layout is very simple, easy to implement in a field condition. And these are the disadvantages. First and foremost disadvantage is its precision is lower as compared to the RCDB design, and the new entries are unreplicated, so the error distribution is very less reliable. The strong dependence on the performance of a check variety is there, and it is not suitable for final yield evaluation trial. When you have to evaluate your lines or a few lines, then you have to go for a RCDB design instead of augmented RCDB design. But for initial screening, it is very good. So these are the steps that we are going to perform in augmented RCDB design. You have to conduct the augmented RCBD experiments. You have to grow your checks in replicates, and the test entry are non-replicated in your blocks. And after conducting your augmented trial, you have to collect the data for yield and yield related characters. After collection of data, you can use the appropriate software like Agri Analyze for estimation of block effects. And once you get the block effect, you can adjust your treatment means. And once you have adjusted treatment means, or once you have adjusted treatment entries, then you can go for a comparison of your adjusted means, and you have to rank them in your among your treatments. Once you give the rank, you give the ranking, and then you have to go for a selection. After ranking, you have to select the best top performing entries out of your all tests. So now we are going to start randomization and layout preparation using Excel. In augmented mapping design, it is very important to randomize our treatments, our checks, and it is very important to draw a layout. When we are planning to sow the seeds for augmented design, we need a layout, and which is randomized totally for our checks and for our treatments. Okay, so we have to prepare the layout and randomize our all the tests and checks. So we are going to perform this in Excel file. I have provided you the Excel file naming random. Okay, so you have to open this random Excel file. Please open this random Excel file that I have provided you in the link. If you do not have this file, please download it from available link. So the information is given here. So there are total 4 blocks. Okay, there are total 4 blocks are there. The entries in entry section, you can see there are 4 checks and 4 tests. Okay, in each block there are 4 check and 4 tests. Total we have a 4 check and total 16 entries are there. Total 16 test entries are there and 4 checks are there. In each block there are 4 checks and 4 test entries. Okay, the test entry 1 to 4 is available in block 1. Test entry from 5 to 8 is available in block 2. Test entry from 9 to 12 is available in block 3. Test entry from 13 to 16 is available in block 4. So these are the information, and we are going to randomize this test and entries using the rand function in an Excel file. Okay. So for randomization, you have to write a rand function. You have to write RAND in bracket close, and you have to copy your treatments here. And you have to write the function rand, and you have to close the bracket. So you'll get this kind of value, and you have to drag these values. Okay, so now you have the random values. Once you get this kind of random values after rand function for your block 1, you have to select both this column of rand function and column of our treatments of block 1. Once you select both the column, you have to go to the A to Z filter. A to Z filter is given in the right side in the upper position. So after selecting that, you have to go to the custom sort. Once you select the custom sort, you have to select your first column, which is J. And if you click on the OK button, all your treatments for block 1 are randomized. Okay. So our treatments, which are check and test entries, are randomized. We have to just copy it, include it in a block 1. Okay. So for block 1, our treatments are randomized. Our check and test entries are randomized. Okay. Likewise, we again have to randomize our block 2 entries and check. So these are check and test entries are there. So again, you have to select both the column, rank function and treatment column. You have to select, and you have to go to the A to Z filter. In A to Z filter, you have to go to the custom sort, and the rank function is already selected here. So you have to put it, you have to select OK button, and all your treatments and check are randomized for block 2. So you have to copy it in a block 2 here. So for block 1 and block 2, our checks and test entries are randomized. Now we have to randomize our check and treatment for a block 3. Okay. So again, you have to select both the column, then function and treatment column. Then you have to go to the A to Z filter, and you have to go to the custom sort, and you have to click on OK button. Okay. So after that, you have to select all your randomized treatments and checks for your block 3 and you have to paste it. Okay, so now we have to randomize our treatments and checks or test entries and checks for block 4. Okay, so for that we have to select all our checks and test entries and you have to put it here in treatments and you have to select both the column, rank function and treatment column. Once you select that, you have to go to the A to Z filter and you have to go to the custom sort. The rank function is already selected here. You have to click on OK button. So you will get the randomized check and test entries. So you have to put it here in block 4. So all our block 1, 2, 3, and 4, all the entries and checks are randomized. Okay. So after that, you have to put it in our layout. So this is our layout. So you have to select your randomized treatments for block 1 and you have to go to the paste. In the paste, you have to go to the paste special and you have to select the transpose. Once you select the transpose button, all your vertical randomized treatment are arranged in a horizontal manner. So you have to cut it from here and you have to put it on your block 1 layout and you have to just adjust it and layout for your block 1, the randomized treatments and checks or your randomized treatments checks and test entries are settled in the block 1. Now you have to select your randomized checks and test entries and you have to paste with the transpose function. Once you select the transpose, all your randomized checks and test entries are arranged in a horizontal manner. You have to cut it and put it in your layout of block 2. Okay, and you have to just set it. So all our block 1 and block 2 randomized entries are settled in our layout. Then you have to again select your randomized checks and paste entry and you have to paste it to transpose function in a paste option. So all your randomized treatments and checks are arranged in a horizontal manner and you have to paste it in your layout. Now same you have to follow for block 4. You have to paste it from transpose function in a horizontal manner. You have to put it in a your block 4 layout. Okay, so our layout is ready. So you can use this layout randomization. You can use this randomized layout for showing purpose in your field. Okay, so it is very important while you are while performing augmented design in the field. So this method is a manual using Excel. You can perform this using this Excel file also, and also you can randomize the augmented your treatments and checks using our Agri Analyze platform. Okay, so now we are going to see how to randomize checks and test entry using our Agri Analyze platform. Okay, to randomize checks and test entry in augmented RCDB design, you have to log into our Agri Analyze platform. All of our participants are requested to log into our Agri Analyze platform. Please log into our Agri Analyze platform so we can perform the randomization of our treatments and checks for augmented RCDB. Once you log into our Agri Analyze platform, please give me a confirmation in a message. So we will start the randomization using our Agri Analyze platform. So please, all the participants logging to our Agri Analyze platform. You have to go to our Agri Analyze platform, agrianalyze.com, and you have to go to the login page like this. You have to enter your registered email ID and you have to write your password in this manner. Okay, and you have to log into our Agri Analyze platform. All the participants are requested to log into our Agri Analyze platform for randomization of our checks and test entries for augmented RCDB design. Once you log in, you will see this kind of a web page. So in this web page, in the menu bar, you have to go to the analytical tool. You have to select the analytical tool. In analytical tool, there is an option genetics and plant breeding. In a genetics and plant breeding, you have to go to the augmented RCDB. In augmented RCDB, you have to select the augmented RCDB layout. All you have to select this option, augmented RCDB layout for randomization. Okay, so once you click on that, you will see this kind of a web page. So I have provided you a file layout, a file naming layout. If you see here, this kind of file we have provided you. You have to just open this file and you have to arrange your checks and treatments. Okay. So in this layout file, you will have this check and entry. So you have to type here check 1 to check 4. Please type manually. You have to type check 1 to check 4, and you have to type here test entry number 1 to test entry number 16. Okay, in a check column, you have to type check 1 to check 4. In an entry column, you have to type test 1 to test 16. Okay, all you have to open the layout Excel file, and in layout Excel file, we have provided you the check column. In a check column, you have to write check entries CK1 to CK4, and in the entry column, you have to write test 1 to test 16. Once you type this checks and entry, you have to save it. Okay. After saving this file, you have to go to the file and you have to go to the save as button. Okay. In Agri Analyze platform, whenever you want to analyze any of your design or any of your experiment, the Excel file, you have to convert it into the CSV format. Okay. For analysis, we need our Excel file in a CSV format. Okay. So after arrangement of the data, you have to convert your Excel file to the CSV format. Likewise, we are going to save our file in a CSV format. You have to go to the save as option. In the save as option, you have to select this CSV format. .csv format, you have to select and you have to again save it in your desired folder. Okay. So we are going to use this CSV file. Okay. And you have to delete your Excel file for layout. Okay. Now I have CSV file. I am going to use this CSV file for randomization and layout preparation in our Agri Analyze platform. Okay. So this is a .csv file. What we have do, we have add our checks and treatments in our Excel file. Then we have saved this our arranged data file in a CSV format in our desired folder. My desired folder is Augmented Design. You have to make your own desired folder and you have to save your data file, the layout file in a CSV format. And then we can carry out the analysis for layout preparation and randomization of our Augmented Design. Okay. I think all you have logged into our Agri Analyze platform. Once you log in, you have to go to the genetics and plant breeding. In the genetics and plant breeding, you have to go to the Augmented RCDB. In Augmented RCDB, you have to go to the RCDB layout. So you will see this kind of a Augmented RCDB layout web page. In this web page, you have to upload your arranged data file for randomization. You have to upload your layout file, your layout CSV file. You will see the Excel, this comma delimiting name here. You have to check it and you have to upload it here. Okay. So our file is successfully uploaded here. You have to upload this file and this file is successfully uploaded here. Once you upload the file, you have to select an entry column. You have to select the entry option here. Okay. So you have to select the entry and here in a test entry, you have to write 4. Okay. In our, if you see here in our data, we are planned to put 4 test entry in each block. Okay. So this is our layout that we have prepared. So in a block 1, we have 4 check and 4 treatment. Block 2, we have 4 check, 4 treatment. In block 3, we have 4 checks and 4 treatment. In block 4, we have 4 checks and 4 treatment. Suppose you have a 5 entries in a block 1, 6 entries in block 2, 7 entries in block 3, and 8 entries in a block 4. Then you have to put here data 4, 5, 6, 7, 8. Okay. Block 1 is having 4 entries. Block 1 is having 4 entries. Block 2 is having 5 entries. Block 3 is having 6 entries. And block 4 is having 7 entries. Okay. So in each block, we have a different number of test entries. So you have to write in this manner. But in our data, all our blocks are having same number of entries. All our blocks are having 4 entries. Okay. Treatment number 1 to 4 is present in a block 1. 5 to 8 present in a block 2. 9 to 12 treatments are present in a block 3, and 13 to 16. 4 entries, 4 test entries are present in the block 4. So we have to just write a 4. Okay. If you have a different sets of a treatment or test entries in a different blocks, then you have to write it separately. Like I have shown you 4, 5, 4, 5, 6, 7. So your block 1 is having 4 treatments, block 2 is having 5 treatments, block 3 is having 6 test entries, and last block is having 7 test entries. But in our case, our all 4 block is having 4 test entries. Okay, so we have to write 4, and in this you can write any of the number. Okay, here by default number is 42. You can write any of your lucky number, and it will give you a randomization. If we have write 42, if you perform after writing this 42, you will get some kind of randomization and some kind of layout. If you perform the same thing, and if you write the same number, your randomization will remain same. If you want to change your randomization, then you have to write the different number. If you write the same C dot a positive number here, if you input number is 42, then you will get the same randomization. If you change this number, if you change this your seed number or lucky number, then you will get the different kind of a randomization. Okay, if you are not happy with your randomized data, okay, then you can change this number. You have to again upload the file and change this lucky number 22 or 23 or 2 or 3. Then you will get the different kind of a randomization. Okay, so write this, keep this lucky number as a 42, and we are going to submit this button. Okay, so you will get the summary. So we have total 16 test entries, 4 checks we have, 4 test entries we have, and number of blocks are 4. The lucky number is 42, and these are the some pricing policy. And today we are going to perform on the free basis because we have provided you the free access to our platform today. Okay, now you have to submit your data, and you will get the download option in a new web page, and you have to download your file. So this is the summary. Check entries, 4 check entries are there. Number of checks, number of test entries are there. All summaries are here. Test entries per block. All our block are having 4 test entries, which is given here. All summary is given here. Then in a field book, you will see all block 1. The checks and test entries are randomized here. For block 2, your checks and test entries are randomized for block 2. For block 3, all your checks and test entries are randomized. And also for last block 4, all your test entries and checks are randomized. Okay. Then in the layout sheet, you can see we have total 4 block, and all your treatments for block 1 are randomized. For block 2, all your treatments and checks are randomized. For block 3, all your treatments and checks are randomized, and same for block 4. And plot number 1 to plot number 8 are already given here. The new plot is starting from here, and in the end, the plot number 16 is there, 17 is here in the end, and the 24 is given here. After 24, in a spiral manner, you will have a new plots. Okay, so this kind of arrangement, this kind of layout you will get, and you can use it in your field. So this is all about randomization of our augmented design and layout preparation using Agri Analyze platform. And this is the field view of our augmented RCBD design, how it is available in our field. You can see this kind of a picture in a field. Now we are going to start the analysis of our RCDB data. For that, we have to randomize, or we have to arrange the data in our provided Excel file. After arrangement of data, we are going to perform how to analyze the data for our RCDB design. I have provided you the data file. Okay, so all you have to open this data file or download this data file from provided link. Please download the data file from the provided link, and you have to go to the Agri Analyze platform using your registered email ID and password. So all of participants are requested to download the data file. We are going to start arrangement of data file for. So please open your data file. I think all of you have downloaded the data file. So all you have to open this data file. We are going to arrange the data in a desired format to analyze on our Agri Analyze platform. you need to register. You need to register on your Agri Analyze platform. Then you have to log into our platform. Then you need this kind of data file for data arrangement. After data arrangement, we are going to perform the augmented RCDB analysis. So all you have to open this file and you have to arrange the data in this manner. You have to select in column 1, we have a block. Block 1 is given here. In column 2 or column B, we have entries. For block 1, total 4 checks and 4 entries are there. And the character is here, grain yield. All the data for respective checks and test entries are given in column C, and the trait is a grain yield. Okay. So for block 1, the data arrangement is already completed. So we have to take the data for block 2. So you have to cut the data of block 2 from here and paste below the block 1. Okay, like this manner. Okay. So now we have a data arranged for block 1 and block 2. Okay. Likewise, you have to cut the data for block 3 and put it below the block 2. And likewise, you have to cut the data for a block 4 and put it below the block 3. Okay. So likewise, you have to cut the data from respective blocks and put it in this first 3 column. Okay. So after cut and paste this kind of data from respective block, you have to select the column E from column E to column O. Select the column E to column O and you have to delete it. Okay. Like this. If you do not delete these columns from column E to column O, then the platform will show you an error. Okay. So it is compulsory to delete from column E to column O. Okay. So after deletion, your Excel file is ready. Our data is arranged in this format. Okay. And please give me a confirmation that you have arranged data in a required format. In a chat box, please give me a confirmation that all you have already arranged the data in a desired format. So we can perform the upcoming steps for analysis. Yes, Ganesh Ram?
Yes.
Okay. So I think all of our participants have arranged the data in this required desired format. So after that, we have to save the file and we have to go to the save as option. I have told all of you that we need our Excel file in a CSV format for analysis. So we have to save as our Excel file, arrange data file in a CSV format. Here the CSV format option is available here. You have to select it and you have to save this one. Okay. So you have to see where your CSV file is saved. Here I can see here, this is my CSV file, data arrange file, CSV file, and this is my Excel file. So I'm going to delete this Excel file because I cannot use this Excel file for analysis. I need this CSV file for analysis. Likewise, you have to save your arrange data file in a CSV format. Then and then you can analyze your augmented data. Okay. So after that, you have to go to our Agri Analyze platform. And again, you have to go to the Agri Analyze tool, analytical tool. In that, you have to go to the genetics and plant breeding option. In genetics and plant breeding option, you have to go to the augmented RCDB. In augmented RCDB, you have to select augmented RCDB analysis. You have to select this option. Once you click on this, you will see this kind of a web page. Okay. Or you have to go to the Agri Analyze platform. On Agri Analyze platform, you have to go to the genetics and plant breeding in analytical tool. In the end, you have to go to the RCDB and you have to go to the augmented RCDB analysis. Okay, so you will get this kind of web page. In this web page, you can see here the tutorial is already available. Okay, the tutorial is available on YouTube. How to analyze your augmented RCDB design. So if you see this, all the things are already explained in this tutorial. You can use it as a reference. You can also download the input file from here. Okay, if you want to perform the augmented RCDB data, this is our input file. And if you want to directly see the output file, you have to click here and you will see the output file. Okay, so all our results are here. Okay, and this is the methodology that we are doing. Okay, so this is our methodology. So here the upload option is there. We have to upload our arrange data file. Okay, you have to select the block, the check you have to select the entries. Again, you have to select the alpha levels of significance. Okay, so by mistake, if you select this option, then you have to again upload your data file. Okay, so all the things are set, and we have to click on the submit button. Once you click on the submit button, you will see the summary. Okay, in summary, you will see the total 4 blocks are there. Total checks. 4 checks are available here, and the test entries are 16, and total 32 observations. And here, the traits where lower means are better is a blank. Okay, if you have selected the gray nil as a lower means, then it will reflect here. Then you have to again perform all the things using augmented RCBD. Okay, so you have to check here. This should be blank. Okay, and these are the pricing policy, and we are going to analyze on the free basis for today. And you have to select this submit option. Then in a few seconds, you will see the results in a new web page. Okay, so in a new web page, we have a download option. You have to download the result file, result zip file, and you have to put it in your desired folder. So I'm going to put it in my result folder here, and you have to open this zip file, and you have to extract all your results in your desired folder. Once you extract it, you will have all the results. So I'm giving you 5 minutes to perform analysis. All the participants are requested to arrange data, to convert your Excel arrange file to CSV format, and perform the analysis by your own. I'm providing you 5 minutes. In 5 minutes, you have to analyze your data, and you have to extract your zip file. Then we are going to see the interpretation from our results. Okay, so take 5 minutes and arrange your data. If you have any problem, then you can ask me in arrangement. But arrange your data and convert it to the CSV format and analyze your data. Okay, I'm going to give you 5 minutes. Extracted your result zip file. So this kind of file you will get after extraction. So this is our augmented RCBD analysis report. You will have this kind of report of our analysis. This is a summary. Number of blocks are 4. Number of checks are 4. Number of test entries are 16. Total number of treatments are 20. And number of rate is 1 grain yield, and the significance level and the 5% selection intensity, or which is used to calculate the genetic advance at the end. And this is our rate grain yield and the null hypothesis. The null hypothesis are there is no real difference in our block, or there is no variation available in all our blocks, which is HO1 and HO2 is there is a entries do not differ for a grain yield. Any of our entries are not differing in a grain yield, which is our HO2, and HO3 is the 4 check varieties are having equal mean. All checks are having equal means. HO4, that is representing the all 16 test entries are having equal means. There is no difference among test entries. So these are our null hypothesis, and this is our first ANOVA based on treatment adjusted. We have adjusted the treatments based on adjusted treatments. This ANOVA is generated, and this is the interpretation. And we can see here all the blocks, treatments checks, and checks versus test versus checks are given here, and all the mean squares are significant, highly significant or significant mean square are available for blocks, for treatments, for checks, or for test versus check. Okay, so all our null hypotheses are rejected because all our block are showing the variations, all our treatments are showing variations, or our checks are showing variations based on the mean square, and treatment versus checks is also showing the variation. But if you see in an interpretation, you can see here the block effect, the block mean square are computed from all the plots. So all the plots we have computed the block effect, So it is confounded with the test entries. We have not removed the test entries in this treatment adjusted ANOVA. Okay. So this is not desired ANOVA because we have also considered the test entry. We have not removed the test entries from the blocks. Okay. So you have to rely on a block adjusted table. Okay. We have to rely on a block adjusted table, which is given below. Okay. If you see here below here, this is a second ANOVA, block adjusted ANOVA. So we have to rely on this block adjusted ANOVA in which we have removed the treatments. Okay. So we have to rely on these results. So in these results also we can see all our treatments are highly significant. All our checks are highly significant. Our treatment test entries versus checks are also highly significant. And our block is also highly significant. That means all our block is having variation and it is worth using. In interpretation also you can see all our block is having some kind of a variation, environmental variation are available in all our core block. So it is necessary to remove this kind of environmental variation. It is necessary to go for a augmented analysis. Okay. And there is a difference among test entries. All our test entries are significant. There is a variation is available in all our treatments, and our test and check entries. Test and check entries are also significant. So there is a variation between test and checks based on this NO. So after adjustment of a means using this augmented design, we have to rank them. Okay. Or is a tremendous amounts of variation is present in all our treatments. If you see another table, adjusted mean with a LSD grouping. Okay. All our 20 treatments are adjusted based on a adjusted mean value. Okay. Based on the adjusted mean value, we are going to give a rank to all our 20 treatments. If you see here, our first ranked treatment is a check number 1. Okay. So first ranking we have given to the check number 1 because it is having highest mean value, which is 70.75. Okay. So out of all our 20 treatments, the highest performing entry is our check. Okay. And if you want to see which entry is at par with our this check, then if you see there is no treatment is at par with our check. Any of the treatment is not at par with our check. And how you can decide that? Based on this alphabet. Here the alphabet H is available. If any of our treatment is having same alphabet, suppose this test number 1 is having same alphabet H, then you can say that all this check number 1 and treatment number 1 are at par with each other, but it is not that thing. The alphabet was G. So different alphabet is indicating that they are not at par with each other. Okay. So highest performing entry is our check 1. If you want to see which of our test entries is performing better among the all 16 test entries. So test entry number 1, which is having highest mean value, okay, which is 60.06 for grain. Okay. And with this test entry, the check number 4 is a at par because it is having same alphabet G and G. Okay. So treatment number 1 and check number 4 are at par with each other for grain yield. Okay. So you can decide based on the ranking. Okay, so automatic ranking is given in this analysis, and you can decide your superior entries out of your test entries. Okay, and then these are the CV and CD information which is used to calculate these rankings and provide this alphabet and grouping. And you can also decide on the basis of this graph. Okay, in this graph also you will see the same information. In this graph you can see this check 1 is having highest mean value. Check 1 is having highest mean value, and out of 20 treatments, any of the treatments is not having the at par value with check number 1. Okay. So check number 1 is the best performer. And if you see out of all the test entries, test entry number 1 is having highest mean value. And the check number 4 is at par with test entry number 1. So test entry number 1 and check number 4 are at par with each other. And likewise, based on this alphabet, you can see the at par value based on least significant differences based on this graph. And the explanation, same explanation are also given below this graph, and you can also use this for interpretation purpose. And after ranking and arrangement of your ranks for different treatments, if you want to see the pairwise comparison, if you want to compare your check and test entry based on CD value, you can also compare all the combination of your checks and treatments based on this pairwise comparison table. Okay. Whether there is a significant difference is available for respective treatments and respective check, or between treatments and between check based on CD value. You can also see the significant difference between your variety check or trade test entry in a question. Okay. So after pairwise comparison, we have all the grand means for respective plots. Overall adjusted mean is given here. All the check means for respective plot are given, and also there's a means for block effect are also available. And in the end, we have a genetic variability parameters. Okay. So in this variability parameters, you have all the genotypic variance, phenotypic variance, environmental variance, GCV, PCV, and ACV is given here. If you see here, there is a high phenotypic variance and the genotypic variance, and there is a less difference between genotypic variance and phenotypic variance, and also the less difference is present between GCV and PCV, and environmental variance is also low. So you can see that there is a less influence of environment on our gradient character. And if you see the heritability of a character, heritability God sense is a high for our character, and genetic advance as percent of mean is a medium, low to medium. Okay, so based on that, we can see that high heritability for our character and medium genetic advance. So our character is governed by non-additive gene action, and selection is not rewarding. Based on this results, you can go for a heterosis breeding based on this particular results. And the same inference or same interpretation is also provided here. The GC and TCV differ by 0.1.001 difference, which is very small. So variation is largely genetic, while there is a little influence of environment. And if you see the broad sense heritability is large and genetic advance is a medium, and together high heritability with a low genetic advance suggests the non-additive gene action, and you can go for a heterosis breeding in a future. So this is all about genetic parameters. And in the end, you will see this kind of a graph where you can see the heritability and genetic advance for this gradal character. There is a high heritability, 82.4%, and medium genetic advance, 18.4%. That means there is a non-additive gene action is present, and heterosis breeding is rewarding. And these are the references which are used for this analysis, and different DCU, PCV heritability parameters are also given in a reference, and you can cite us using this kind of a citation form. Okay, so this is all about our results. And in a data file, in extracted data file, you will see the Excel file also. Okay, so this is the adjusted treatment ANOVA, block ANOVA, adjusted means and rankings are there that you can easily copy from here to paste in your thesis or in your research work. And these are the different parameters, genetic parameters, which are calculated. And attractive images are also you can use in this PNG format for heritability and for rankings. Okay, so this was all about analysis and interpretation part. Now let's move towards the case study. Okay, so very small case study on a genetic variability studies for yield and its attributing traits in rice F4 mapping population. So the location was Hyderabad, and the population was F4, which is made from TI 128 by BPT 5204. And the test entries are total 192, and 5 checks are there. The blocks are 8, and the traits are 10. And the experimental design was a augmented RCBD design. And this is the analysis of variance based on your augmented analysis. So in this analysis of variance, you can see all the mean square values are significant for treatments, for check, for test versus check, and for block. For number of tillers and productive tillers, it is significant, and for rest of the characters, it is non-significant. So you can say that for number of tillers and productive tillers, there is environmental variation among the blocks are present, and for rest of the character, there is a less or negligible amount of environmental variation is present. And table 2 is representing the estimation of genetic variability parameters for our mapping population. And in this table, you can see that the character, number of tillers per plant, number of productive tillers per plant, spade value, field grains per panicle for the number of grains per panicle, and grain yield is having high heritability with a high genetic advance as percent of mean. That means our character, all these characters are governed by additive gene action, and selection is rewarding. And also based on PCV and GCV, there is a less difference between GCV and PCV values. So we can say that there is a little influence of our environment on our studied character. So this is all about case study, and this now we are going to talk about tools that we can use in Agri Analyze platform. There are various kind of tools that you can explore on our Agri Analyze platform. So these are the different sets of tools that you can explore on Agri Analyze platform. The CRD design is there, and RCBD design and its various factors are available here. Flip flow design is also available on our Agri Analyze platform. The data transformation methods are also available. And if you see for genetics and plant breeding, there are different kind of analysis method available. Genotypic correlation, phenotypic correlation, path analysis is there, cluster analysis is available, dial line by test analysis is also available, principal component analysis and stability analysis also available here. Then you can also perform the different kind of correlations like Pearson's, Spearman rank, and regression analysis you can perform here. Hypothesis testing is also available. Multivariate analysis techniques are also available like PC and path analysis. And this is a separate from Agri Analyze platform. You can also use our Excel tool. You can demand Excel tool based on your requirement on the given contact information, and you can design your own Excel file for your respective analysis purpose. So this is all about today's session, and thank you all of you. And this topic is open for discussion. If you have any queries related to the augmented design or for analysis, you can ask the questions. Am I audible to all of you?
Hello.
Hello.
Dr. Patel. Am I
Yes, sir.
audible?
Yes, you are audible, sir.
Yes, sir. So, a very good morning, I must say. I'm Professor Roy from Uttar Bunga Krishi Vishwavidyalaya, West Bengal.
Yes, sir. Yes, sir.
Yes. And I have gone through your entire lecture. I did analysis also on
Yes,
the
sir.
Agri Analyze. So, my
Yes, sir.
appreciations for your excellent presentation of a little bit difficult design that we
Yeah.
generally do not do.
Yes, sir.
So,
Yes, sir.
thank you.
Thank you,
Thank
sir.
you very much for your nice presentation, sir.
Thank you,
So
sir.
yes, sir. I just have one or two issues to just discuss.
Yes, sir.
Yes. That is, sir, that is there any thumb rule for number of blocks? Say, I have 100 genotypes. I can go for 10 blocks. I may go for 25 blocks. And of course, four number of checks in each.
Mhm.
So is there any thumb rule, sir, in a very simple way?
Uh, Generally, we are using the square root technique, square root of n. Okay, if you have a 200 test entries, then you have to perform the square root of 200, so it will become around 15. So you have to go for a 15 block. So formula is there, square
Oh,
root of n.
okay,
Okay.
sir. Okay. And
But practically
within
speaking, we are not following that. Practically, we are not following all this
no,
technique.
it is there
Yeah.
depending on actual
Yeah.
scenario.
So resources. Yeah, sir.
Yeah, I was just asking because sometimes, no, in
Yeah.
seminars, some
Yeah.
statistics teachers ours they ask these
Yeah.
difficult questions. So I
Yeah.
was
Yeah.
just asking for a
Yes.
thumb
Yes.
rule.
Yes. Yes, thumb
Okay,
rule is
and
there, square root of n. Number of n means number of your test entries. Based on that, you can decide your block numbers.
okay, and number
Uh,
of checks within a block. Uh,
Number of
Regarding that,
checks.
sir.
Generally, we have at least four checks you have to
Yeah,
keep.
we are going ahead with four,
Yeah,
but is
four
there any?
checks. But there is no standard thumb rule, as far
Okay,
I know now,
okay,
as per my knowledge. There is no standard thumb
okay,
rule. But, generally, we are keeping four checks.
okay,
And so
and
practically, we are not randomizing the checks also in
yes,
our
yes.
experiments. It's depend on scenario and our requirement.
Okay,
But
okay,
yes,
sir. Okay, sir.
based on statistics rules, we have to randomize all our tests and checks also. But that we are not practically using because there is a difficulty in data collection and all.
Yes. Practical
Hello,
scenario
Suvendra
is
Kumar.
this.
Practical
Hello.
scenario is very
Hello.
different.
Suvendra Kumar.
Yes,
Number
sir.
of
Yes, sir.
yes, number of checks is depend on you, but number of replication, it's depend on number of checks.
Okay.
You
But
get
there
it?
is number of blocks depends on number of checks, sir.
Yes, sir. Yes. How?
Okay.
Because one statistic rule is there in design of experiment. Your degrees of freedom for error, it should be minimum 12.
Yes.
Okay. Okay.
Yes.
Now
Yeah.
you are taking four checks. Okay. So in RRBD, there is a error degrees of freedom for equation is r minus 1 into t minus 1.
Yeah.
Okay. So here t minus 1 it is 4 minus 1 it is 3. Okay.
So we are
Four,
in a safe
okay.
position.
4 minus 1 it is 3. Okay.
Yeah.
So 12 divided by 3 it is 4. So number of replication is required for your augmented design, it is 5. How I put message in chat box. Okay.
Okay.
T minus 1.
Hello, Darshan.
Hello.
Yes.
Yes.
Darshan, please answer Himul Sutar. We have some question related to this.
Augmented RCBD analysis and GCV, PCV, and heterosis and genetic advance is carried out as per which method? It's depend on like you have to do variability analysis, then you can perform variability analysis in our Agri Analyze tool. Then here we have many analysis tool in planting like L by T, diallele, half diallele, then augmented design. It's based on your research. You can perform your data analysis in Agri Analyze tool.
Yes.
Okay.
I have already subscribed your.
Okay. Well. Thank you so much.
I extensively use your software because it is so easy and good to very nice to interpret from
because in
your results.
if you are not know for programming in like Python and R, so this is the basic tool and easy tool for performing your data analysis. Because in agriculture, number of students are not understand and not learning about programming language because it is very tough for our agricultural students. So yes, it's a basic and easy to analysis for your very large area of our Agri Analyze tools like experimental design and plant breeding analysis also is there. So this is very easy and better understanding for all the agricultural students and researchers.
Yes. Excellent, sir. Sir, just one or two more issues I wanted to discuss, sir.
Yes.
May I?
Hello?
Sir. Yes. So, sir, what I was saying is there is another design which I communicated with your contacts, that is the alpha lattice.
Yes, alpha lattice.
So yes, sir, because you are so sound in all these things. So if that could also be included.
Yes, sir. We are performing in this. We are in very short time. We are launching this our new tool like alpha lattice design, and there is too many designs in incomplete block design. There is alpha lattice, whereas incomplete block design, so many. So we are performing in this because this is very tough to analyze. Okay. So in programming, there is a very testing. Too much testing is required for these designs.
Yes.
In short time, we are easy to interpret and easy to analysis. This is alpha lattice design in our Agri Analyze tool.
Thank you so much. And just a final one, I just had to, because I'm getting an opportunity to talk to you. So I was just saying, sir, that nowadays combined analysis is done across environments or years, whatever it is. So your Atkins test that is done, so when we do the stability, it already does that kind of test, the chi-square test, homogeneity of error variance test, and then it automatically transforms depending on the requirement for transformation. Now, my request was, sir, that if homogeneity of variance test, since you already have the logic with you, that is the software logic with you, if that homogeneity of variance test, chi-square test, bullets, could be kept as a separate option. Why I say, sir? Because practically in agronomy, other than breeding, in agronomy and other streams, people do not go for homogeneity test at all. Although they do a lot of combined analysis.
Yes, I understand. There is many data is there, like heterogeneity is there in our data. So actually, if heterogeneity is there, then you cannot perform. So we have done this. Your question is very good. So we can perform in this.
Yes, sir. And another one, sir, just another transformation that is which you already do. It is there in your system. That is separately Atkins transformation. Separately, if it could be done, like you have an option still for certain kinds of transformations, a separate Atkins transformation, so that the logic to the students will be very clear that now I'm getting a significant test for homogeneity error variance. So now again I can further go for Atkins. This will make the logic very clear. Otherwise, prior to your software, none of the softwares had this logic very clearly mentioned. Nowhere I could find. Even in TNU software, I interacted with their all their scientists who prepared that software and all. They don't go for homogeneity test and all. They directly go for stability test. So my request, because I always insist my students to follow your logic, that is Agri Analyze logic. So that is why if the Atkins transformation could be placed separately and the homogeneity test also as a separate option.
Okay, sir.
So that the
we can
students
perform this like we give you two separate options like for Bartlett test and transformation. So we can
yes.
Okay.
The students' logic will be more clear.
Yes.
Yeah.
So researcher can perform this better way. This is a very basic idea behind this concept.
Yes. So thank you very much from
Okay.
my side, and a lot of appreciation to all of you.
Thank you so much, sir.
Thank you, sir. Thank you very much, sir.
Thank you very much. Thank you very much. I'll be in touch with you. Yeah. Thank
Okay,
you.
okay. Thank you, sir.
Thank you.
Thanks. So can we consider this this one as can I leave the session, sir?
Yes, sir. Yes, sir.
Yes,
Yes,
sir. If
please.
you have any queries, then you can leave your session.
Okay. Thank you. Thank you very much, sir. Thank you, sir.
Okay.
Okay,
Thank you,
sir.
sir.
Thanks.
Other participants, have you any query?
Excuse me, sir. Hello?
Yes, ma'am.
Oh, excuse me, sir. So I have one query.
Yes, sir. Yes, ma'am. Please.
Sir, for my experiment, I have around 95 genotypes.
Okay.
So, sir, I have replicated it into 4 blocks using 3 check varieties.
Uh-huh.
So, sir, for each block, how many entries can be there for 3 checks?
3 checks. Okay.
Yes, sir.
So first of all, if you have a 3 checks, okay. So if number of replication is required for 3 check is I think 7.
Yes, sir.
Okay. R minus 1. So the T minus 1 it is you have a hello.
Hello. Yes, sir. Yes, sir. I can
You
hear
have
you.
3 check.
Yes, sir. I have 3 checks.
Okay. So number of replication is required for your experiment. It is 7. Okay.
Yes, sir.
First of all, you have to divide your 95 genotype into 7 blocks. So
Yeah.
95 divided by 7. 1 minute. 95 divided by 7. So 13. I think 14 into 7. I think you have to include number of checks is 3. It means if you have a 95 genotype and 3 checks, okay. So then
Yes,
you
sir.
have a perform 7 block. For better dividing your 95 genotype into 7 blocks, you have to include another 3 checks for 3 genotypes in your research, and now you have a 98 genotype or 98 treatment. 98 treatment.
Yes, sir. Yes,
Okay.
sir.
And 7 replication. Okay, I put this message on
Yes, sir.
chat box. So number of block per number of checks, number of treatment per block is 14. Number of treatment, it means number of genotypes per block is 14. Okay, are you understand
Yes,
how
sir.
it is
Yes,
performed?
sir. Yes, sir. I can understand. Yes, sir.
Now you have 14 genotypes per block and 3 checks. It means you have a 17 treatments per block. Here I
Okay.
correct in this chat I correct this one. Number of genotypes
Yes,
per
sir.
block is 14 and number of treatments
Yes,
per block it is 17.
Yes, sir.
How it's performed, you get it?
Yes, sir. Yes, sir.
Okay.
So, sir, that means it's a thumb rule, no? So we can't just place the genotypes in each blocks without the thumb rule.
Here thumb rule is that number of first of all you have to decide number of replication in your research. Okay, based
Yes,
on
sir.
number of checks. If you have 3 checks, then we have a 7 replication or 7 block.
Yes, sir.
But here you have 95 genotypes, so we cannot divide 95 genotype in each in a 7 replication. So here you have to include another 3 genotype in your research. So here we have a 98 genotype, and 98 divided by 7 it is 14. It means 14 genotype is required for per block, and another 3 checks. So here you have a total 17 treatment or 7. You have a block size is 17. Here block size is 17.
Yes, sir.
Okay, so this is
Yes,
the
sir.
thumb rule.
Okay, okay. Thank you.
Okay, thank you, ma'am.
Okay. Anyone have any query regarding this analysis or any doubts, you can ask. Okay, Darshan, can we complete now?
Yes, sir, please. Okay.
Okay.
Thank you all the
Thank you.
participants for attending this today's session. And once again, thank you, Dr. Savan Patel, for giving this
Thank you, Darshan.
amazing webinar on augmented design. Okay, thank you so much, sir.
Okay. Thank you, all of you.